What up, YouTube squad? Space weather incoming. Major solar flare in the region that we said was active on Friday. So won't you join us for some updates when the CME is going to impact Earth? We'll talk about the X2 class solar flare that was associated with the latest incoming solar storm. We'll look at forecasts from University of Reading, things like the sunspot number, coronal holes, and so forth. So thanks for tuning in. Congratulations on realizing the channel exists. If you're new, press subscribe. Otherwise, you won't see the world's most comprehensive daily space weather content, which is propaganda and nonsense free. Propaganda and nonsense free. So yeah, there's a big one on the way. And this one could cause major geomagnetic storms. Fingers crossed for that. We want to see aurorae at mid-latitudes. That is one of the highlighted things that occurs. So always excited to see such things happening. We'll show you the data about the sunspot number, the North Pole-oriented coronal holes, and so forth. So let's do it. We are in the studio. So let me just fire this thing up here, and we'll get you squared away on what's going on with space weather. So we got a massive snowstorm here. It was a multi-day event. I believe it was over actually a total of 3 days, Friday, Saturday, and Sunday. Finally stopped last night with another like 3/4 of an inch, maybe, something like that. So I was a little bit disappointed last time as we got shortchanged on the snow, but this time it was a little bit better. So that's always nice. And let's see what's going on with things like sunspot number. And we'll even talk Earth weather at the end of the stream. So stay tuned for that if you're interested in seeing some Earth weather forecasts. This channel does primarily space weather because Earth weather is far too easy to forecast. That's why. So there's that. Yeah, you gotta have challenges, folks. If you're stagnating, getting stuck in the same old boring routine, snap out of it. Do one thing differently. It'll lead to other things, and that'll lead to other things. Evolve or die, folks. Evolve or die. And let us know in the comments about your personal evolution. It's always interesting to hear what people are doing differently. All right, so first of all, we'll take a look at this closest star, the local yellow dwarf El Sol, sometimes referred to as Helios. Let me just move the camera here a little bit. Pardon the guerrilla style filming. It is just, we get higher coherence for these streams when we shoot the videos in portrait mode as opposed to landscape mode. I guess because most people view on their devices. I don't know. That's a guess. That's a guess. So what do you got? What do you got? Again, an X-class solar flare did occur. And a massive Hyder flare right in the center of the solar disk. It's pretty epic. So let me shrink this down. There we go. That's pretty good. Shows you time and date stamps. We'll bring this way back. Oh, let it refresh. It's well worth it, folks. While that refreshes, let's take a look at the CME forecast here from U Reading. Okay. Let's try that again. Nothing happened. All right, and we're running that in Google Chrome. There we go. Yeah, so the brunt of that CME is headed right toward Earth. I mean, you can see right there the densest portion, and it's high speed. High speed. So University of Reading is forecasting the impact of this latest CME to occur sometime around midday on the 20th. So tomorrow midday, folks, it's this is a fast mover and it's going to cause a major geomagnetic storm. Don't be surprised to see a KP8 or even a KP9, like a G4 class geomagnetic storm could be generated from this one. It is very much earthly directed, as you can see here. And that's good news for those in the realm of space weather. Is it going to shut down civilization, destroy all electronic devices? Well, absolutely not. This is a fairly common occurrence, this sort of a CME. But we're excited to have it on the way because mid-latitude aurorae may be coming tomorrow evening, especially for places like Lehigh Valley, Pennsylvania, where we're located. Maybe going into tomorrow evening. I mean, this is going to be a long-lived thing because look at that. It looks like it's, according to you, Reading, that is going to be the duration of the solar storm. It's going to last well into the next day. So it looks like it's going to finally hit the trailing edge there around 9 o'clock Universal Time. That's 0900 UT. So let's bring this back here to show you this epic coronal mass ejection and indeed flare. There it is. That is very much pointed toward Earth. So now, just while we're here talking about flares, solar flares are photons, folks. Don't get them conflated. Do not confuse solar flares and coronal mass ejections. Coronal mass ejections are protons. It's gas, mostly hydrogen, coming out of the sun. There is also some helium in there, some electrons, and some other heavier elements. But it's primarily ionized hydrogen that comes out of a coronal mass ejection. That is what causes the geomagnetic storms, not the solar flares. So we constantly hear people sort of conflating the two, and they really aren't similar. They are separate phenomena. We do see coronal mass ejections regularly without a solar flare, and we do see solar flares regularly without coronal mass ejections. This one, fortunately for us, has both. So now you're going to see a secondary flare as well popping up here. That's called a Hyder flare. That is when plasma splashes back down toward the chromosphere. So right in there you can see, right in here you can see, so here's the flare. And you can see a CME happening over here, right? No flare associated with that one. Solar flares are photons, X-ray photons. So think of that like light. It is just, X-rays are just high frequency light, folks. And the coronal mass ejection is matter. Think of like a fan blowing air. That is, this gas is quite diffuse by the time it reaches Earth. However, it does carry its own magnetic field and so forth. So it does represent electric current flying through space in its own little plasma cloud. Now, you will notice to the northwest, which is above and to the right, you'll see this brightening in this area right in here. That's called a Hyder flare. That is when plasma doesn't make it out of the sun's gravity, succumbs to that gravity, and gets pulled back down toward the chromosphere. The chromosphere is the transitional region below the corona being the sun's atmosphere. The chromosphere is where it gets much more coherent. It's a very thin transitional layer, and it is above the photosphere, which is where sunspots occur. So that's as deep as we can see into the sun is a sunspot. When you see that black sunspot, that is like a black blocker that those strong magnetic fields prevent us from seeing deeper into the sun. So the photosphere is as deep as we see anyway. There's that flare and Hyder flare and CME. Now keep in mind when there's a CME headed directly toward the camera, there's not a lot of contrast there. So it's tough to see, but yeah, there's a major CME there, and it's a fast mover. So this one's probably moving at like 900 kilometers per second, maybe even over 1,000. So yeah, that's what's going on. Um, let's see if any additional. Well, let's hit some other data points here. You can expect cosmic ray flux to drop even lower because we're going to have another 4-Bush minimum when this CME hits. So expect DOMB and DOMC and OLU neutron monitor and Mexico City and Athens and Thule to see a big drop in cosmic ray flux as that solar plasma arrives. These are just the X-rays from one of those cosmic ray producers. That's Cygnus X3. That is from the Neil Gorell's Swift Bat X-ray Observatory. If you want to look up your favorite stellar objects, just go to the Neil Gorell Swift Observatory. And for example, here's Sagittarius A star. That's the core of the Milky Way galaxy, entry number 710. And there are Sagittarius A star's X-ray emissions. Here is going back about 21 years. This is 1 year, and then this is 30 days. Oh, that's daily. That's 1 day. This is 30 days, and this is 21 years. That's the X-ray output of the core of the Milky Way galaxy, Sagittarius A star, the massive radio source around which many other massive stars orbit. Another one you may want to look at would be the Crab Nebula, right? If you type in Crab, one of the entries there is indeed the Crab Nebula, the Crab Pulsar. And there it is, entry number 185. Oh, and check it out. Since 2021, the Crab Pulsar has become quite active in terms of its X-ray output. So anyway, the Neil Gorell's is an interesting place to view the X-ray emissions for all kinds of objects. Another interesting one, of course, is Cygnus A, the radio galaxy, which is also known as 3C405. That is the strongest radio source in the sky. Again, this is X-ray, though. This is not radio. But there is a distant galaxy located 500 million light years, about 530 million light years distance, and still the strongest radio source besides the sun. So anyway, SIG X3 is SIG space, CYG space X-3. That's that cosmic ray source that's located at 32,000 light years distance in the Milky Way galaxy. Again, CME to arrive tomorrow before midday. It's a fast mover. It's going to cause a major geomagnetic storm on a global scale. So that should be exciting. Current conditions are pretty nominal here. Only 290 kilometers a second for the solar wind velocity. That's incredibly slow. That is about as slow as it ever gets. If you see 270, it's really getting close to as slow as the solar wind ever gets. And as far as the density is kind of nominal here at 1.7 protons per cubic centimeter. And the magnetic field situation is pretty uninteresting, right? This is nominal as well. So the field is 9 nanotesla with a BZ, that's the vertical component of the magnetic field, a BZ of -0, otherwise known as zero. Zero, it has no absolute value. And just a quick reminder, that solar wind is measured way out here at Lagrangian point 1. It's about 1 million miles from Earth. That's the location of the ACE spacecraft, which is what we've used for this data today. Space Weather Enthusiast dashboard here is agreeing with University of Reading largely. They're calling for up to a G3 class geomagnetic storm. That'll be around midday tomorrow on January 20th. So Tuesday, January 20th, should be a day of space weather all day long and into Wednesday. Like I said earlier in the video, NOAA's forecast agrees with our forecast. And I mean, I'm based on University of Reading and what I saw myself. The radio flux has come way up, as you would expect, with major solar flaring happening. Radio flux now back up to 187 on the SFUs. That's solar flux units. The 10.7 centimeter radio flux. Sunspot number now up above 150, folks. So we've had major sunspot growth, or perhaps rising sunspots, which we'll also view here from some ground-based observatories. But there is sunspot number reported by Royal Observatory, Belgium. Next, the coronagraph, which is going to show a major halo for that incoming CME. And there you can see it. You can even tell that it is high speed. If you're familiar with looking at the GOES 19 coronagraph, that's a good one. We've also got planets here that's, and the moon making an appearance. Wow, that was awesome. That was freaking amazing. Anyway, we've also got Venus and Mercury and Mars on this imagery. If you're wondering what those other celestial bodies are, that's what they are. There you can see that massive CME just as the moon comes into the frame. That is, that's a pretty good highlight there for all y'all space weather enthusiasts. That's a good one. That looks freaking awesome. So yeah, that's a GOES 19 satellite. That's located at about 25,000 miles of altitude. GOES satellites are geosynchronous. That's why they are at such a high and slow orbit. They're at such a slow orbit that they're in a geosynchronous orbit. Next, we'll look at stereo A, because you're going to see that CME coming out of the left of the frame on stereo A. So let's show that. The delightful coronagraph on stereo A. We love it because sometimes the other coronagraph isn't showing us what we'd like to see. But there it is. Just a massive CME there. Some missing frames, but the Earth would be off in this orientation from stereo A. So, I mean, just to give you an idea of where it is, you know, stereo A, here's Earth, right? Stereo A is like 30 degrees out like this, a couple of months ahead of Earth in terms of orbit. Stereo B is located around this area. So, yeah, major CME headed toward Earth. Good times. This is where planets are located. As you can see, we've got Mercury, Venus, and Mars there. Also, Pluto is kind of in that line. Keep in mind, this is not to scale. Planets are really far apart. Oh, we got a major proton event too. So this is sort of a rarity, but significant proton event here. I mean, not the most significant of this solar cycle, but the low energy portion of it here at pretty high levels. So some additional radiation there can be expected if you're on a polar flight or if you're an astronaut, because those are extremely high energy protons orbiting Earth's magnetic field lines, and it's well, I mean, look at the voltage. The voltage is 10 million volts, or 10 mega electron volts. The blue is 50 million volts, and the green is 100 million volts. Barely even a blip in the 500 million volts. But that will represent some additional radiation if you're like flying over Greenland or something, or if you're on the International Space Station or taking some sort of a space flight. Here's that flare. Let me shrink this down to a 1 day. It's a long duration flare. Peak flux was around 1800 Universal Time. And those protons, they took about 5 hours to get there. So that's what's going on. We usually don't see proton events, but that's a major proton event. So expect a major 4-Bush minimum from that incoming coronal mass ejection as well. Like I said, a major reduction in cosmic ray flux is coming Earth's way. Next, we'll look at the heliospheric magnetism. Like I said earlier, Earth is in a North Pole-oriented magnetic sector, as depicted here. Oh, and by the way, this shows stereo A and B. So here's stereo B. It's a little further behind the Earth. Then stereo A is ahead, as you can see there. But those are the locations of those. They do provide the data out here to complete this product. It's the top view ecliptic plane field plot. It's depicting the heliosphere's magnetism. Here is our coronal hole line of sight plot. Like we said, North Pole-oriented coronal holes are in charge of the current earthly environment. There are some South Pole-oriented in here, but you can see they're actually moving toward the pole. That is a feature of the solar cycle. These coronal holes will eventually fixate at the heliographic poles. And that's what we call solar minimum, when we have enduring coronal holes at the poles. Next, we'll look at the magnetism here, since we've got such a big uptick in sunspot number. Let's go with Cerro Tololo. We'll stay as close to our own longitude as we can here by looking at the Chilean magnetogram. Oh yeah, we've got sunspot growth here. So, well, let's show the red light. We'll stick with Cerro Tololo, and we'll just show today's data here. That is January 19. Wow, that's a lot of sunspots, folks. And these are magnetically complex, so we could see major flaring continue to happen here. Like, look at this. This is a beta class, at least beta gamma class. This is probably beta gamma delta class. More sunspots over here. Like, that's a major uptick in sunspot number, folks. There are the magnetograms. This is still the best place for major flares. We have the most magnetic shear here, but there's plenty up here as well. So don't be surprised to see M or even X class flares just east of center longitudes. Plenty of chance for more major flares and more earthly directed CMEs. Fingers crossed for that. Now, here is our hydrogen alpha imagery. This is red light, by the way. That's red light. This is the magnetogram. This uses the Zeeman effect and polarized light to determine the magnetic field orientations. This is red light, 677 nanometers. And this is hydrogen alpha. So now you're just looking at the hydrogen on the closest star, and you can see there are still, wow, look at the size of these filaments. So now some of these collapsed, but some of these did eject as well. There is still plenty of plasma to blast off of both of these areas. I mean, look at how much activity there is there. This is a very three-dimensional portion of the sun right now. There are huge filaments that are kind of oriented out toward Earth, associated with these live regions, these active regions here, especially this sunspot and this sunspot. Those two groups are legit. So as far as the last image here, I mean, this is a filament that's worthy of a name. If you want to name filaments on Twitter, just put the hashtag, name that filament, and tag at Smash-O-Mash, and we'll name filaments after your friends, your foes, or even yourself. We name them after living people because solar coronal plasma filaments are lively, like most humans. Especially the ones who don't have their heads up there you-know-whats. The ones who do, though, their ride is nearly over. Their ride is nearly over. Because fraud only lasts so long, and then people catch on to it, and you lose your credibility, never to regain it. The electron storm continues, and expect very high levels of electron flux and bad performance from your GPSs, because they have to communicate through a lot of electrons, and this is what they're looking at. So this is their total electron content forecast. expect major electron clouds, especially around the equator at noon. But we're going to see ionization. I mean, we do have ionization of the polar regions right now as well. In fact, we're actually going to show that today because we have a proton event going on. So let's bring up the deabsorption regions. What? What the heck? There we go. There's the DRAP predictions. I think that's the right one. Yeah, there it is. So now when your GPS satellite has to communicate with your handset, it has to communicate through like 25,000 miles of atmosphere, and portions of that are ionized, especially the portion, under the noontime sun. So when we have proton events, we have even more ionization going on up there. This is the total electron content forecast. This is where you can expect the GPS errors to be the worst throughout the day. That does include the timestamps. But here is the deabsorption region. So polar radio blackouts are currently occurring, like complete blackouts, especially at the South Pole. And you can see even at the North Polar region, there are some full blackouts. This is because the proton event, it causes the ionosphere to basically go berserk and prevent it from reflecting radio signals back down to Earth. So it's essentially like an opening of the ionosphere because the signal just goes out into space instead of being re-emitted by the ionosphere. So as you can see, all bands here up to 15 megahertz are being blasted into space. All right, let me see if I have the... And as you can see, there is flaring going on. So what happens is you get a radio blackout under the sun, right? Wherever it's noontime, you get a blackout there when the flare occurs. But when the proton event occurs, the protons, they're still hanging out up here. They're still orbiting the polar field lines. So anyway, that's a little bit about how that works. Hopefully that helps you. And this is just a map of the layers so that people understand where space weather starts and ends. And really where it starts and ends is at the sun and the D region. So the D region, when you get below the D region of the ionosphere, this is mostly neutral atmosphere. This is mostly ionized. This is the line between space and Earth weather, and let's cross it. Yeah, crossing the line, folks. But first, we'll show the ionosphere, just an image, a current image there. There's the current image of the vibrational frequency of the F layer. So that's just this region right here. Depending on if it's day or night, the altitude varies. But there's the F layer. And there's the anomaly in megahertz from a 30-day median. So expect lots of anomalies in this. In fact, let's actually show we're going to show the anomalygram animation for the past day. Because there should be some perturbations in there, and oh, geez, it doesn't look like it's going. Oh, there we go. All right, perfect. So there's the ionosphere, and you're seeing lots of low-frequency anomalies happening there. South Atlantic anomaly. What's up with that? Is it in the South Pacific now? The African anomaly still appears to be right here, by the West African coast, right on the equator, is about where the African anomaly appears to be located. The South Atlantic anomaly, I don't know. Is it down here at 30 degrees latitude now? It was up here at the equator, right on the west coast of South America at the equator. So I guess I better bring up the other animation, since I can't comment on this because I have insufficient data. So yeah, this is anomaly in megahertz from the 30-day median. And here is the raw frequency. In megahertz, that's millions of vibrations per second. Interesting. Perhaps the South Atlantic anomaly is on the move again. I've been watching this for the past 2 weeks or so, and it does not appear to be here anymore. Is it down here? It looks like it's actually here, way down at the 30-degree latitude line and way out in the Pacific Ocean. So if so, it's moved thousands and thousands of miles to the south and west. It was over here, and it's been toward the center of the continent. So the South Atlantic anomaly appears to be on the move for weeks. It's not because of the solar flare or the CMEs. Or if it is, the mechanism is very much unclear. But anyway, that's what's going on with the South Atlantic anomaly. It's unclear as to where it is currently located. Now, like I said, we're going to cross the line here because we're going to move into the realm of Earth weather. We're actually going to show more frames here. How about 40 frames? Since we're coming at you a little later today, there's the full sunrise. How you like them apples? All right, and thanks for leaving comments, a Barbarian 1111, and also Orange Sunrise. Cheers. Yeah, thanks for commenting. So yeah, that's if I shrink that down one more size, we can show you the time and date stamps. That is quite recent data indeed, folks. Let me just move the camera a little bit here. There we go. That's not too bad. Fantastic orange sunrise, and we hope you're able to forecast your weather, and we hope that you understand that Earth is most definitely shaped like the French breakfast pastry, Croissant Earth Society. When will you stop believing NASA's lies? What do you think, Earth is shaped like a sphere? What kind of psycho are you? Didn't you know NASA was founded by a Nazi? So here's the U.S. water vapor map. That's going to give you a great picture of the general state of things. We've got cold air blasting down into Montana once again. Thanks, Canada. Thanks for all the cold air, Canada. A fine job you're doing up there. A fine job. Love the government. I mean, governments are just, they're so competent. Pardon my sarcasm. So here is the U.S. Doppler radar map, and we've got lake effect snow continuing all around the lakes. Look at the freaking, that is wind-generated snow right there. Look at that. That is bonkers. Look at that. That is lake effect snow, classic lake effect snow. And some's moving across PA, so it looks like we'll get some more today once again. That's what happens when you pray for abundance, folks. Watch out what you wish for. You just might get it. But if you don't wish for it, you probably won't get it. We do have some precipitation here across the hot air capital of the U.S., Colorado, as well as Kansas. Well, anyway, there's the map. That's why I'm showing it. I don't got to explain it. Why do we have video in the first place if I got to explain it? Here's a great satellite map of the Western Hemisphere. I can even move this over and show Europe, Africa, and the Near East. How about them apples? Windy.com, they got a great mobile app if you've never seen it. It's pretty sweet. Here's the blue light version. Hey, how about the infrared version? This shows you a little more detail, folks. It's going to show you water vapor. Since water emits a lot of radiation. Barb asks what the function of the South Atlantic anomaly is. It doesn't have a function. It's a feature of nature. What do you mean, what's the function? It's the Earth's weak point in Earth's magnetosphere. So what makes it relevant is that there are huge variations in where the ionosphere is located in terms of altitude. It might show the movement of the core. However, we don't really have any information that's suggests that, right? So extraordinary claims require extraordinary evidence. Do we see something changing with the core at the same time that we see the South Atlantic anomaly moving? Not really. So I don't know why it would show the, quote, movement of the core. And some believe the core is solid, and there's a lot of conjecture, and it's a really son of a bit turn sort of a thing. Pole reversal? I mean, the South Atlantic anomaly would move around a lot during a pole reversal, but we would typically see a polar excursion before seeing a pole reversal. And we ain't got a polar excursion. We have barely a blip on the geologic radar. So, what's going on with the pole shift that everybody keeps talking about in our comments is not even worthy of really paying any attention to, because the poles are always moving around. The poles are never totally stationary because of, I mean, look, if it's plumes of molten iron that are in charge of generating Earth's magnetic field, then that's not the core. And the generation of Earth's magnetic field would affect how the ionosphere is oriented and shaped and so on. So yeah, it could show movement of the core, but we don't know that for sure. So let's we're going to show some maps here. We're going to show a 72-hour pressure and precipitation map. This is going to show snow and rain and mean sea level pressure. So there is that map. That's a 72-hour GFS forecast. And we'll have a little bit of respite of the cold temperatures later in the week here in PA, but then it looks like more snow is headed through toward the end of the week. Oh, I've got a bunch of dead files here. Let me get rid of those. And we'll show some more forecasts here. We're going to show 2-meter temperature anomaly because we've got some very, very cold. We have a high forecast below 20 for one of these days for eastern Pennsylvania. So here's your temperature anomaly forecast. That's in degrees Celsius. It is the same 72-hour GFS model. That is a temperature at 2 meters altitude. So we'll have anomalously cold air and then some anomalously warm air. And that's how it works. Last but not least, we'll show total positive snow depth change. That is the major logistical challenge, as we are snowed in here in Lehigh Valley, and a lot of things are not going to be working normally for a while. So, but there's a scenario. It looks like no new snow in the next 3 days. 72-hour GFS accumulated positive snow depth change forecast in inches. Heaviest snow is coming too. Yeah, wow. Look at the area east of Ontario here. Yo. 2 more feet plus. Over a foot more coming east of Erie. That is lake effect snow in spades. Dude, look at that. It's calling for like 4 feet in some areas there. So yeah. Hit us up on social media if you've got like snow that's taller than you are in your backyard. We'll share the photos on the channel. All right, so we'll take a brief look at Earth's jet streams next. Instead of showing a forecast, we'll just show the current jet stream scenarios. Right now we're looking at ocean waves, and there's wind. Here are the surface winds of the eastern Earth. So the Pacific is quite turbulent here. Also the Southern Ocean, quite turbulent. Quite a few lows chilling here. Here are the jet streams of this side of the planet. Very coherent jet stream over the North Pacific, and a very jumbled up jet stream here over the Southern Ocean. Bringing some cold air into Southern Australia. Jet streams of the central world. There you go. Shout out to our viewers from all around the planet. Once again, congratulations. We're frankly surprised that you were able to find the channel. We've had plenty of trouble finding our own videos on YouTube. Many, many dozens and dozens of times. Here are the surface winds of the central world. And look at the heavy winds on the eastern Mediterranean. Dag! Sicily has got some surf. Sicily's got an onshore wind. I wonder how big the waves get in the Mediterranean. Let's take a look, shall we? There's not often very good surf in the Mediterranean, but let's see what's going on. Ocean waves. You know, sometimes Bermuda has surf. 13-foot waves there at Sicily. How you like them apples? 13-foot waves at Sicily. It's pretty sweet. Let's look for the world's biggest waves. Southern Ocean, it looks like. And there is no surf to be had, nor in this area by the Aleutians. I think these are the biggest waves, though. Probably like 30-footers. 28.5 footers there. And back to our regularly scheduled jet streams and surface winds. So there are the jets. Here are the jet streams of the Western world. And the surface winds. Look at those crazy winds on the Great Lakes, especially Michigan there. The Windy City really blows today. Chicago getting kaplastered with wind. Let's check out the waves in Lake Michigan, since some people surf there, believe it or not. I know it sounds bonkers, right? But yeah, you get a dry suit, you can surf Lake Michigan. If it's not frozen solid, it's probably frozen solid. All right, what do you got? Oh, it doesn't show waves for the Great Lakes. You son of a... It shows sea surface temperature anomaly. Anyway, while we're here, there is a sea surface temperature anomaly. And there are ocean currents. Some of the more interesting ones are the ones that circumvent the poles in the Southern Ocean. Also, these South African currents are super interesting. But the most important one for the Northern Hemisphere is this current right here. It stops the Northern Hemisphere from freezing into a giant block of advancing glacial ice. Anyway, just thought I'd mention it. I don't want the split view. I want to show 171 angstroms and close out this video. So anyway, thanks for tuning in, everybody who has found the videos. Like, yeah, we're surprised. We're literally surprised that you found the channel for real. So yeah, that's ionized iron, folks. That's the 171 angstroms wavelength. It's the house favorite wavelength. Now keep in mind, it's not really that color. And look, we've got filaments interacting between these sunspot groups. So that is a recipe for additional massive CMEs. And look, they're right in the center of the solar disk. So this is a recipe for additional incoming space weather. That is what we want to see. That's exciting stuff. Shout out to people who know what they're talking about, like Tamitha Skov and Sarah Husial and Scott McIntosh, and let's don't forget Bob Lehman. You know, actual current scientists, although Tamitha would argue that she's not a current scientist. She is the ultimate authority in space weather. So, of course, she doesn't do daily space weather videos, and I don't blame her, because it's a lot of work. And it's frankly unrewarding, because most people don't care and do not understand anything about it. But yeah, we've got some on the way. It's always exciting. It's a delight to have you here viewing the content. So thanks for tuning in. Don't forget to leave a comment, press share especially, and visit the homepage smashomash.com to do just that. There you will find our social media and so on. So press that share button, tag us on social media, and we'll consider following you as well. So thanks again for tuning in, folks. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted name in news. And until tomorrow, when the CME arrives and causes major geomagnetic storming, may that solar wind be at your back. And thank you, racy star. We'll close out with 131 angstroms. This is one of the best wavelengths through which to view flares, and maybe we'll even stream the sun later, just because like I said, don't be surprised to see more X-class flares or M or X-class flares out of these spots as well. So, yeah, good times for space weather, and we'll see you tomorrow.